sum of the power of the concentration which is shown here. So sum of the power of the concentration term should be same for the representing an elementary reaction. If the sum of the powers of the concentration and the molecularity is the number of moles that involved in the reaction, particularly. So if it's same, then it's elementary reaction, and the reaction mechanism will be in a single step. There is no intermediates. Okay, so there is a direct conversion. We And we've been talking about the rate of the reaction, and the rate is just a formation or the disappearance. We can either way we can connect this. And here the rate is the function of concentration, temperature, pressure, and the type of the catalyst, if any. The type of the catalyst, I already said that we don't involve much here because it gets more complicated. Because of the size, pores, and its surface area, and its surface activeness, and the absorption, desorption, so many terms of that. But in our part, we only talk about the elementary homogeneous reactions. So homogeneous reactions are mostly we talk about the concentration and the temperature. Homogeneous means mostly we will involve with liquids. Okay? That's where we start actually. And the concentration, temperature, pressure. And it is independent of the size. So we keep volume as constant here. That is why it is independent of the size of the reactor or the reaction system. The volume kept constant here. And this is an algebraic equation, not a differential equation. But it shares d, Ca by dt, is definitely an algebraic equation. If you see, for example, a graphical representation of the concentration versus time. You see here, the concentration is actually decreases with the reactant. This is a reactant concentrations, okay? So the reactant concentration will start to decrease with respect to time. So for 0th minute, you take the concentration is somewhere 1.7 mole. And for the next 50th minute, it is 1.2. And for 100th minute, it's 0.8. And for 150 minute, it's 0.6. So the concentration of the reactant keeps on decreases. So if you see the overall representation, it is like this. So it's keep on decreases with time. At particular point, it reaches 0 at particular time. At particular time, the concentration becomes 0. That means it is 100% converted. When all the reactants all get converted into product. That is what, or some other species. That is what it means. Definitely, it is not required to be a product. It can be any other things. Okay, so that we will see later on. And if you see here in this, for example, we take propylene or butylene. You see the initial concentration starts with 0.1 molarity, and it keeps on decreases. And at the instant rate, that is at time 0, you say the instantaneous or the initial rate. So here the initial rate represents this slope. So if you take the slope, that is the initial rate of this particular reaction. That is how they will assume the rate first before they were trying to find out the real rate. Sometime if you want to see at the time 600 second, if you draw a tangent, then this tangent will give a slope. So this slope will be the value of the reactant. So this might be that if you want to fix your reactor, to be operating at this particular residence time. So your molecules, your reactant molecule has to spend 600 seconds in the reactor. So that is what you are like you fix in your design. Then the rate will be calculated according to this. Okay, I hope you will understand here. And why we fix the time means it actually comes with your idealness and the non-idealness behavior of the reactor. That we will study more detail later on, because you must know what is the steady state and unsteady state, and what is the ideal condition and the non-ideal condition. Even though you built a reactor, not all the reactors are an ideal reactor. For only the theoretical purpose, we consider as an ideal reactor. Whatever you study now, we consider this reactor as an ideal reactor. Okay, so the ideal reactor will be just fixed for the sake of our assumption. Once you do the standard error like analysis, you start to do the modeling and let's try to find out how much it deviates from the ideal. According to that, you will find out the reaction time here, or the residence time. Okay, so you will find a mean residence time by using some statistical tool, and that will be kept as your calculation point, and then for that you will take the rate of the reaction from this graph finally, and that will be used for your design purpose later on. Okay. Similarly, if you see the product concentration, it is vice versa to the reactant. As the reactant concentration decreases slowly down, it is exponentially decreasing, because we have said it is a dCA by dt. In this particular term, if you represent in the graphical term, it represents the differential form. But if you take it in the normal calculation, it takes in the arithmetic form. Okay, that means the gradient directly. But if you put it this in the graphical form, the rate, it is in the differential form. That's why the differential decrease in the graph. Similarly, like opposite to that, it is a differential increase. So the differential equations will play here to calculate the rate of this particular uh, reaction. Okay, but if you have the value, you can directly find your rate by the arithmetic equation. Here, what will happen if you calculate by arithmetic way or the algebraic way or by the differential way? Means it's only the error difference in your calculation. The standard deviation error in your the standard deviation excuse me, can you hear my voice?
Yeah, sir.
Yes, sir.
Okay, so there's no problem there. Okay. If you see that there is an if you take in an arithmetic value, that is delta Ca by delta T, so this is an gradient value. So here the error might be somewhat higher when compared to you calculate by using a differential. Okay, so the error can be reduced. This is how you are using the Newton-Raphson method or your numerical analysis method here. So you can even use that methods to reduce the error. That means you can increase the decimal value. If you keep on increase the decimal value, that is after the full stop, there is a decimal value can be increased. If you increase the decimal value, so there is more and more appropriate or an accuracy will be there in your calculation. That is what it means. Okay. So before I just come into some discussion, I want to remind you that For the parameters of effective rate of the reactions are already said. It is about the nature of the species, concentration, temperature, catalytic activity, if any. Nature of contact of the reactant, heat and mass transfer in the system. You see here that the nature of contact of the reactant and mass transfer of the systems are almost closely connected to each other because it talks about how the molecule move from one phase to another phase. Similarly, temperature, the outside the reactant be different coefficients and the ultimately. Okay, this is why it is all connected to each other. These are the parameters that really affect the rate of the reaction. Okay, from now onwards, I request you to have always a pen, a book, and you always keep one or two, three graphs with you. Okay, if you don't have graphs, please keep a scale. Okay, so that you can draw graph by on your own. Okay, sir, is it clear? Anyone?
Yes,
Hello.
sir.
Okay, good. So try to keep pen and your notebook because we are going to work out problems every day, at least one small problems, and we are going to see a lot of graphical work in this particular subject. So try to keep a graph or you keep an scale which has a scaling so that you can draw a graph by on your own. And a calculator is a must. Okay, so that is the thing. Now we are coming into a very interesting part. So we start with a very simple calculation. Determine the rate of running by Mr. Usain Bolt. I think everybody knows Mr. Usain Bolt. With respect to different distance covered in Olympic Games. So here is the distance covered, that is distance taken in a meter, and here is the world record. Okay. Now you have to find the rate of running, how speed, how fast he can run. So I want you to calculate the rate for this particular data. Very clear, sir. I just post it one more time. Yes. Now can you see the data, sir? Madam, everybody? Hello?
Yes, sir.
Yes,
Yes, sir.
sir.
Okay, so now you are planning to calculate a rate for this. So please take down the data with you. So what I'm going to do is that I'm going to call particular person and I want you to show in the video camera how were you calculate it and what is the result. So make sure that you are doing it and make sure you are doing this calculation. Sir, have you completed it? So I can call some of you and ask this. Okay. I see there is someone who has put the answer. Very interesting. Okay. I see before the voice get break. Is it still a problem, sir?
No, sir.
Okay, very good. I see there is so many datas. Very interesting. Anyone? Data, yes. Welcome. Either Prasant was very close to the answer, actually. Bhushan Roy was very close to the answer. Even Anand. Aishwarya was very, very close. And Deepak was very close. So that was really exact. Yes. Is there anyone representing your answer, sir? So if you represent your answer, we can discuss because may come with different answers that might not suit. And I will say why because here. For example, I see Bhavyashri was actually said 8.4. Kartik Raja was 10.4. Yes, you see there is a two different values when compared to fuel. I will ask Dakshinamurthy. Mr. Dakshinamurthy.
Sir,
Yes. How do you get your value, sir? 9.96.
sir,
Just
first
give a simple explanation. Yes, sir.
sir, for individual, I take the rate, sir,
Yes.
and then I calculate the average.
Okay, very good. Okay, sir, that is really good. Okay. Now I call this Bhavya Shri. How do you do this calculation now?
Sir, I use the formula CA minus CA naught by TCA minus TCA naught.
Okay, what is CA and what is CA naught?
Sir, I divided, sir, CA is 400, CA naught is 100,
Okay,
48 minus 9. I divided both the, sir,
9.58, right?
both the different values.
But I think you might represent at the last value, 8.4, you mean. I don't know why you get so less. Because if you divide 100 by 9.58, it is 10.44, right? Okay, we will just come that later on. Mr. Kartik Raja, why you get 10.4?
Right, sir, for five values, and I choose the most repetitive one, sir. Sir,
Mr. Kartik Raja, are you there?
sir,
Ah, ah. How do you
sir.
get 10.4, sir?
First I calculated the five rates, sir, and
Okay.
then and then I choose the most repetitive one, sir. The three values take
Okay,
10.4.
so you took the best one of it. Okay.
Yes, sir.
Okay. Mr. Ajay Satya, how do you get 10.45?
Sir, same method only, sir. I calculated rate for all the five values and chose the repeated values, sir.
Okay, that's okay. That's really fine. So there might be some mistake. You might do that. You just take the average of the distance and the average of the world records, and then you can find the rate. Okay. If you do that, maybe Mahadev Sri Vishnu might do in that way. I think he got really low. I don't know why. Any idea, Mr. Mahadev Sri Vishnu?
Sir, I generally took the rate, sir.
Sorry.
But we'll take the dy by dt.
Okay.
I use that method, sir.
Okay, there could be some problem is that some people might take 100 minus 150. So here it is not in that way. Yeah, the initial is 0. So you start from 0, right? So the distance covered is from 0.2 to 100. So the time taken is from 0 to 9.58 second. So such a way you have to think, okay? So this is the rate. So if you take the average, that average is 9.97. Yes, this is absolutely good. I will put a questions to Gopinath, or no, I'll put questions to Divagar, M Divagar.
Yes, sir.
Yeah, because I don't see your answers here. You see, we have 10.44, 10.45, 10.42, 9.69, 8.84. That means the rate is decreasing if you go with the longer time distance. Okay. And the maximum rate is 10.44 or 45, and the minimum is 8.84 if you go with the longer distance. Okay. Do you accept, sir?
Sir, I cannot understand, sir.
The maximum rate, that is for the lower distance, the rate is high, that is 10.45. Okay.
Yes, sir.
And for the longer distance, for 400 meter, the rate is 8.84.
Yes, sir.
Okay. So the average is 9.97 meter per second, the rate. Okay.
Yes, sir.
Now you say that, what do you understand from this result?
The distance increases, rate increases.
Again, I repeat it. For 100 meter, the rate is 10.44, and for 400 meter, the rate is 0.84. If you see the average of all this value, it is 9.97. Now I put the question and this.
Sir.
Are you still with me?
Yes, sir.
Yeah. Now you say why there is a deviation in result in the value.
Because the rate and the time is inversely proportional.
Sorry, the rate is.
The rate and the
Sir,
time is
you are. No, it's not like that. Yeah, the rate and the time is inversely proportional, we can say. But anyway, you have to be more logical here. It does not give any like the proportionality or something like that. You have to be more logical here. Why? If you see this data, you must start to analyze. That is what you are going to learn from this subject. You do the calculation and you start to analyze why we get this value and what do you understand from this result. Okay, this is what you have to do it in this particular subject. Okay, so we are going to do more analytical work, analysis work. So logical reasoning should be there. Now you say why.
Don't know, sir. Sorry.
Okay, thank you. Miss Harini. Yes, Harini, are you there?
Yes, sir.
Yes, ma'am. Can you say why? I think you hear what we've been discussing. Yeah, you can close the video, ma'am. You can close the video.
It is not.
It will really disturb. Can you say why this deviation?
I don't know, sir.
Okay. Okay. Is there anyone volunteers that you can say why? Any sports person?
Sir,
Yes.
sir,
You
0 to
can say
100
why.
meter. So 0 to 100 meter is a shorter distance, sir. He can run for a time. First shot, he said 0 to 400 meter is a longer distance, so his rate will be decreased over time, sir, over distance.
Okay. Then what do you understand from this now? No, can you say the logical point here?
He may
As an
be
athlete.
tired or something.
You see, once you see this, to start to run, the initial start will be so high, right? Because you have a lot of energy. So the initial start will be covered very quick, right? So the first 50 meter or something like that, you will go very quick and the initial start, you have so much energy to spend. And this energy will be accumulated and start to utilize very quickly. And you go further and further, the energy loss, that is the energy stored in your body will be little low. Like this is like a battery, right? So if you have full charge battery, you get very good power. Once the battery started to down, the power supply will start to slow down. That is the voltage get dropped. Okay. Do you agree, Mr. Karthik Raja?
Yes, sir.
Okay,
Yes, sir.
thank you very much. So this is what the logical understanding here. So this is what you will try to find from this rate. Okay. The next one. Okay, now we thought about, now we discussed about a running race. Now we come into a totally different situation here. Uh, so the water release in Kaveri Basin, this is totally a very different issue. Okay. Here, the TMC, that is 1,000 million cube feet, it's been discharged into water in the river. For different month, you have different flow rates. Can you write the rate for this particular month and then particular month? How much the discharge will be? Here I don't do the calculation by myself. So I want you to do this calculation so that I can see how you are. I hope everybody taking the value, so I go into the things. No, not for a whole year, sir. It's just only the TMC has been released in this water basin. So anyone want data again?
Yes, sir.
Okay, we are very close to the time now, and I would like to discuss now very brief. I just want one or two volunteers to say which month have highest rate. Or if you want whole, I mean, sum up, you can just sum it up all this data directly. And can you say which month? I think August is the highest rate of a discharge, and then September, and then July, October, November, then June. So now you see the rate value here, I hope. Mr. Ajay, can you say what do you understand from this and how we can utilize this data?
Sir,
Yes.
sir, can you please repeat the
Can,
question?
yes. Can you say, I think you might calculate the rate now for
Yes, sir.
different month. So with this data, what you can utilize, I mean, what is the purpose and how you can utilize this data and what are the plans you can make for the farmers?
Sir, by finding the rate, we can find the amount of water we get every day, sir.
Okay.
By that, we can know when we should leave more water to the farmers and when, in which month we should not use more water.
Okay. Do you know which month they actually open and which month they close the Kaveri dam, I mean the Metu dam for the agriculture purpose?
No, sir.
They, they usually start in June and they will wind up in February or the January last. Okay. So they start in the middle of June and they wind up in February first week. Okay. Okay.
Yes.
Now in June, July, August, September, and October, November, you have somehow, I mean, till October, you have somehow good rate. But November, December, January, you have really minimum rate of what is discharge, right? So, what do you understand now?
Sir, same thing only, sir. We will be knowing when to. எப்படி சொல்றது?
When to
Uh,
open
yes, sir.
the gate and when to close the gate. Okay, very good. You see, this is not only that, whenever you have a discharge, high discharge, okay, it is not mandatory just to open the Metu dam, whatever comes in, you have to go out, okay. You need to store it, okay. If the rate exceed this limit, then you must be aware that you must leave some more excess water in the gate before you get this water in. Okay. If the rate is below this, then you must adjust the water such a way that you should not drain out the dam very quickly.
Yes,
Okay.
sir.
So
Yes, sir.
this has to be understood such a way that the engineer in the dam will work out and he will try to adjust the water discharge in the dam, in the meter. Okay, that is why there is sometimes they actually take 10,000 cubic meter, or sometimes they take 15,000 cubic meter, 20,000. Sometimes they reduce 5,000 cubic meter. Depending on this calculation, they will change the flow rate in the river. Okay, this is also a very important thing to alert the disaster management system too. Okay, thank you very much for today's lecture. I think everybody is present. I just stop recording.